So the first thing we're going to do is working in drainage. We've got another toolbar to open. Okay, under View, Toolbars, I'm going to pick off the drainage toolbar. And finish. So what I'm going to run through, don't stress too much. This is, I just want to give an overview so next week it's not too onerous. The drainage package in 12D is certainly for me, is one of the best features it has. The roading is fantastic, but the power behind some of the engines that the drainage network editor uses are fantastic. There's two main design criteria for stormwater systems, certainly in Auckland at the moment. We either design using the rational formula. Has everyone done a hydraulics paper or had some kind of... Okay, so to calculate design flow, it either uses the rational formula, or under the old ARC they had a system using SCS curves, which was in TP 108. Okay, which is irrelevant to you, but what it was is there was a performer within a technical publication that used different steps so that instead of just on a large job having one big blanket, making one assumption for the coefficient of pervious and impervious areas, it allows us to be a bit more flexible and talk about percentages of area that are paved and areas that are long grass and areas that are rocked. Okay, it's basically anytime you get anything of a decent subdivision size, you have to run an SCS curve calculation. Now, the same network editor that we're about to open does both of them. The first time that we run it, we always use a rational formula, and this allows us to size the pipes. Okay, so based on all those things that you know from your hydraulics, you need for your flow under the rational formula, you need a catchment coefficient or a percentage of impervious area. You need a rainfall intensity that comes from a preset council standard. You need an area, and then it gets divided by 360. Okay. Using that and the Colebrook White for pipe roughness and the grades of the pipelines, 12D will size all the pipes within a pipe reticulation system. Okay. It used to, so instead of spending 3 days going through and going through a manual or calculating by hand, it does it in about a second. It's in the same way that the create roads function works. Then if we need to, and we won't go on to use them in this course, I'll just give you an overview, then you can use the same model and then run the SCS curves. You can use it to calculate pre-development runoff flows and intensities and peaks as opposed to post-development, so that you can prove that you're not harming the environment, that your design eventually will either keep the environment, keep the runoff in the same state or better than it was. Okay, we can design detention systems, basins, dam walls, levels of orifices, all that kind of stuff. Okay, it's the longer you use it, and some of you will get to go off to consultants and get pretty good at it. It's really quite amazing stuff. All we're going to do is, obviously, we've only got 3 weeks to cover this for the assignment, so we're going to get into the basics. I'm going to go through some basic defaults in the network editor. Don't panic if you don't get them all this week. By next week when we start using them, you'll see why I'm pumping certain figures in. We're going to create some drainage strings. Under the stormwater ones, we are going to then size the pipes, and we're going to look at different reasons for why, how we lay the drainage out. Just some thought behind the whole design process. Okay. first thing we're going to do is we're going to create a drainage string. Okay, like everything in 12D, I can also come up here and use the pull down menu, design, drainage sewer, and I've got the whole thing here, or I can use the toolbar. Actually, just before we do anything else, I will just set the defaults for this. So the first thing I want you to do is come to the pull down, design, drainage sewer, defaults. Okay, I'm going to preset the default for my finished surface tin. Now I haven't gone and made a super tin yet, otherwise normally your tin design that you used for your first assignment would be the one. Just for the ease of this, I'm just going to use tin ground, okay? So when I open the network editor, the default finished surface tin is ground. And I'm going to set and finish. Come back up, design, drainage sewer, defaults. I'm going to set my manholes. The default manhole for any design that we're going to do is a 1050 manhole. Okay, it's the most common manhole we use in stormwater design. The 1050. Oh, bear in mind that, like everything else in 12D, it's in meters, okay? So when I say 1050, 1.05. So we always refer to them in terms of internal diameter. The reasons for going to bigger, any idea why we go to bigger manholes than a 1050?
Sizes.
Bigger, if there will be a point where pipes coming in and out of the manhole are so big that you have to increase the size of the manhole to allow for that. There's also, once you pass certain depths, they'll have different standards for, instead of the standard little rungs that people can climb in and out of at a 2 metre manhole, it gets to the point where you need a 1200 or 1500 because we have ladders and platforms, and so there's at different depths we may have to go up to a bigger size, and certainly if we get into big pipes then the 1050 is not going to. You can imagine a 1050 manhole is this far across. By the time you put a 600 diameter pipe into it, there's not a lot of actual wall left to join the to fix everything together. So 1050 is our default. The next one is the drop through the manhole. We set the drop to allow for head loss. Now the standard default here is 20 mils through the manhole. Most councils now require a minimum of 30. I always set it to 50 mils minimum unless I get into real problems with grade. Obviously if you've got a line at as flat a grade as you can lay, so 1% or just below, the more manholes it goes through, the more of those 20-30 mils add up. You can sometimes get yourself into a bit of trouble with cover. And again, you'll see this as we get into, but it's extremely hard for a drain layer to come along and plaster the benching if it's only 20 mils across the entire manhole, okay? So from a practical point of view, to make it easy for them, I set that to 50 mils. Okay, I'm not too worried about the default name. And I'm under my type, I've got a pull down menu. This is in the background here there's a drainage.4d file that has a preset list of these things. The logical choice here would be to pick a manhole 1050. There is something weird in the Unitec file that won't allow you to attach a catchment to that. So I'll try a manhole, just the MH, and we'll see whether that works later. But just when it comes to the assignment, that manhole 1050 on these computers for some reason does something funny. Set and finish. And then finally, design, drainage sewer, defaults. We'll set our pipe type. Okay, I'm going to start with a stormwater system. So my default is going to be a 225 internal diameter pipe Minimum grade is 1 to 100 or 1%. Minimum cover, I'll just set as 1 for now.
Is it 1.00 or 100?
The minimum grade is 1 in 100. It's asking you for the 1 in grade as opposed to a percentage. Minimum cover is 1 metre. And the pipe type, there's a couple of different ways of expressing these. The top one here, RCP, is a reinforced concrete pipe. When you look through standards, a lot of the standards in Auckland still will have RC, RRJ, and then a letter. Reinforced concrete rubber ring joint, which is the standard stormwater pipe. They used to be class XYZ. They're now class 2, 3, 4. Okay, so class 2 is a standard pipe. Class 4 is a stronger pipe that we use under roads. Again, we'll cover this. This is just a quick overview. So I'm going to pick a class 2 pipe. Set and finish. Okay, now I don't need to go and muck around with anything. Now when I start to design, it's going to instantly go for those defaults, and we can, if they don't suit us, then we can change them later. So the next thing we're going to do is we're going to create a drainage string. It's a little sunny, happy looking icon right here in the middle of our drainage toolbar. Create drainage string.
This is designing
A pipe for reticulation.
Pipe as opposed to a water
Yeah.
supply pipe.
Yep. So I'm going to do wastewater and stormwater in here, but not water supply.
Okay.
Okay. You can model water supply in here, but we're not going to cover it in here. Okay. This is just drainage. Okay. The naming convention I use, and it will depend. It differs from office to office, but it tends to be standard. It's the more common is that I call my stormwater lines line A, B, C, D, and my wastewater line, 1, 2, 3, 4, and I call my wastewater lines A, B, C, D. It doesn't matter which, but pick one or the other, okay, so that you don't end up with 2 manholes, A1, B2, okay, just to save confusion. Go for letters for one and numbers for the other. Okay, so I'm going to do a stormwater line 1. Like everything else, I keep my my naming convention simple, so that the model that I'm going to put all my stormwater lines into is called stormwater lines. Okay, we end up with running functions on these. You have to put everything into the same model in the same way that our centre lines work. Well, you don't have to, but it won't. The functions won't run properly otherwise. I'm going to click on blue. Does anyone know what the standard colour for wastewater is?
Red.
Red. Okay. So all my stormwater lines are going to be blue. All are going to have a numerical name, and they're all going to be in model stormwater lines. There's 2 different thoughts of trains of thought when it comes to the flow direction. A lot of people, in fact, some of the 12D courses, they start, and the flow direction will be the same as the string direction, and they start at the top of the line and work their way down, saying that's logical because that's the way the water flows. The problem with that is that a drain layer does the opposite. He starts at his outlet and works up. So if I'm creating a set of engineering plans that are there as an instruction for someone to build, then I make my plans the same way as they work. Okay, so this is not a right or wrong, but this is the more practical approach. So the flow direction I'm going to set as opposite to string direction, and I'll start drawing my lines from the outlet and work them up the hill. Okay, and then I've got a finished surface specified in my defaults, so I can now click on create. Okay, as soon as I do that, it opens up its own little dialog box for this specific line. Okay, we don't actually have an outlet or anything. This is just for so I can run through and show you something. So I'm going to pick an arbitrary point as my outlet and then work away from that. I come up here, I go to Edits, Add Append Manhole. Edits, Add Append Manhole. Got that? Just like in the first week, once we start running once I start asking it to do something, it will prompt me for what it wants down here. Okay, so it's asking for the final position of the point. I'm going to pick and accept, and you can see it might be a bit hard to see on certainly for you guys at the back, but it's starting to draw my pipeline in as I go. Okay, so I am going to go and arbitrarily pick some manhole positions just so I've got a complete line. Once I'm happy I've got to the top, I hit escape. Now, so I apologise if you can't see from the back, but if I now profile that string I've created, there is my drainage line starting at the outlet. Okay, it's being built three-dimensionally. If we look at this in perspective, you'll be able to see the pipes and the manholes below the ground. The cyan line running along the bottom is the hydraulic grade line. It's sitting at RL0 at the moment because we haven't given it any we haven't asked it to calculate anything. Okay, so it's come up with the default grades based on the minimum drop through the manhole that I've given it.
1 to 100, is it the 1 to 100 you do?
Yeah, in fact, if I turn on the grades here, just come up to our toggle grades. They won't all be 1%, but the minimum will be 1%. So the flattest line, it's started off and said, okay, I don't have a lot of cover, I'll go at 1%, and that's the default. Okay. So it now has, based on what my minimum cover and minimum grade were, it has a first crack at its alignment. You might find the odd time, in fact, here's one. The outlet, the pipe coming in is too low. It's only because it's just its first default. Once we run the network editor and tell it to regrade, it'll fix all those things. Okay, it's just got in there and stuck to our defaults. Okay, so that's as far as I'm going to go with this for now. I'm going to get into the network editor and start to manipulate it. But these are the different options. Okay, I could have. If I was going to use curved lines for whatever reason, sometimes if you're working with PE, we have bends and lines. Rather than just add an append, I could have gone add append and put a radius in. Move, insert manhole, delete, extend. Okay, it's just in the same way that you can use modifiers for 1,000 things. You can manipulate these till the cows come home. But just for now, I'm going to click save and finish. Okay, all I'm doing is getting to the point where that just disappeared. Here we go. I'll pull that back down so you can see what I'm doing. On the very left hand edge, I have the drainage network editor. Okay, I'm going to click on the left hand icon on my drainage toolbar. and I'm going to select stormwater lines number 1 and accept.
Which one did you select?
So this dialog box here is open from the drainage network editor there, and all I've done is I've pick edit. I've only got one drainage string in here, so I've just picked on my stormwater line. Everyone happy with that? Okay, so what I'm going to do again to try and cover it in the next 45 minutes is just going to be too much. I'll just give you an overview of what's in here. Next week we'll start to play with the stormwater lines themselves. As I move from right to left, we've got a results tab. Now this, if we are using SCS curves, this is where all the information is presented. It gives us dynamic results, graphs to show the pre and post development flows. Also, I think there are about 35 different options for pumping information out to in a nice presentable manner. It only works on the SCS curves, so because we're sticking to rational, we won't be getting into this too much. If we get time towards the end of as long as we're not pushed to get our assignments done, I might come back to this and show you what it can bump out, but this is for SCS curves only. So the first thing that you're going to do is we're going to start setting these tabs working from right to left. Global, and again, anything that we set here as a default can be overwritten later if we want to change a piece of information for a specific manhole or a specific pipe. We can change that later. This is just a starting point for its design, okay? So under our global, this is some of the types of information that it's after. Whether we're working in metric or imperial. What our finished surface and natural surface tins are. What kind of calculations we're performing. Whether it be rational or New Zealand SCS curves. Okay? It defaults to rational, and that's what we're sticking to now. Has anyone ever come across in hydraulics? Did you cover SCS curves?
Highway.
You did?
In highway.
Oh right, okay. So basically you're assigning. If I say that X percentage of this campus's land is totally impervious, then you assign a value for that, and it runs on a number from 0 to 100 basically, and obviously the higher the number, the more impervious. Okay, so different types of agricultural ground can have quite specific curve numbers, as opposed to the rational, where we just tend to, in a subdivision, give it a blanket 0.65 as a C value. Okay, there's the differences aren't exorbitantly different between the two, but the SCS curves are a lot more accurate, or incrementally. Okay, we can preset things like our impervious levels, the defaults, with a maximum of C maximum of 1. What I would do is for this assignment, to make sure that you don't have problems, because we are only setting one C value, whenever it asks you for in the defaults, just so you don't get it wrong, set that to 0.65. Okay, it's not going to be relevant to something, but just anywhere you find that it asks you for a default value for pervious and impervious, just give it a blanket 0.65. Okay, that's all we're going to work on. That's what the council standards are, and that's based on X size of lot with X size of house on it, X size of paved area, a certain amount of lots per street. Okay, they've come up with 0.65 as a decent average number for them to use. Okay, so that's under the global main tab. Under our utilities models, I'll go through, again we'll get in and play with these next week. I've actually provided under the week 5 notes, I've provided all the background files that you don't have to go through and create your own, that you can download them now off Moodle if you want. It's there for you to see under week 5. But all of these preset defaults, you don't have to worry about. You can just pick more ones. Okay, the catchment file is just a file so that when all the polylines that I've drawn within that catchment file, when I hit set catchments, it will try and assign the nearest area that I've circled to the nearest manhole, so it tries to work out what we're trying to do as far as the reticulation goes. That will all become evident when we start to play with it. Okay, with label models, the type of textile that we have, overland bypass flows, I don't think we will have time to get into that for this course. Basically, this is what happens if a manhole blocks completely, how much water is getting into it. If it can't all get into that manhole, where does it run to? Can that next manhole take it? Can that next cesspit take it? We can do all that kind of, so you're working out how much can fit under the ground, and then if it ends up in overland flow, what do we do with it? Okay, I'll see how we go for time as to how far we push into that. Okay, so the utility models are just there as we're just setting defaults. So that's our global tab. We're giving it the type of calculation we're performing and the kind of models we're using. Right, so the next tab across is defaults. We have 3 different data sets that we set defaults for here. The first is catchment. Again, it prompts us for a % impervious, so change it to 65. If they're all set to 65, you can't go wrong. I'm going to, again, anywhere it prompts me for a C value. The other thing I want you to do is set all of your time of concentrations to 10 minutes. Okay, there's our catchment defaults. Under our pits tab, under defaults pits, we're going to set the cover mode for the for our manholes. Make sure both of them, the RL cover and RL and great RL, are both finished surface tin. And basically, what that's going to do is it's going to set the manhole lid at the tin level, at our design level. KU method is the loss through the manhole. You can either go through and under the council standards you can work out for each pit what it is, or I find if you just stick to the default there of 2, it's conservative, but it gives you a design. Then if things are a bit pushed, you can always go back to the individual manhole, work out what it is, and pull it back if you've got the flexibility. I like to go for a factor of safety in these things. It means you're slightly over design, but there's nothing worse than the first time it rains having manhole lids pop off your drains. You look like a bit of a knob. Okay. Set out data is the other thing we're going to set here. Set out XY mode is the pit centre. Set out Z mode is the cover RL. So our manhole lid is going to end up at the finished surface, and we're not using a road. The last defaults tab is our pipes. Now this is something. One of the stipulations in the assignment is that things have to comply with council standards. Definitely the council standards we're using, and in fact 99.9% of them, will only, they ask for manning for open trapezoidal type channels, overland flow, but for pipes they require Colebrook white. And the roughness we're going to use is 1.5 mils. This is how we're sizing the pipes, okay? We're taking our rational formulas giving us our flow. It's then going to run a Colebrook white calculation, and using the grade, the roughness and that flow, it's going to give us the required pipe. Our invert design, we can leave the grade mode at minimum depth. Our downstream alignment mode though has got to be changed. It's got to be obvert level to obvert drop. And I'll show you on the board. I apologise it's not going to show up on the camera, but if you can just turn so you can see this. Here's our manhole. Sorry guys. If I have a 225 pipe out and a 225 pipe in, the difference vertically between this point and this point is going to be what? Anyone know? It's going to be 50 mils, because that's the drop that I've told it that I'm going to use it as a default. Okay, so if it's the same size pipe, it's going to apply that minimum drop. If I have a 450 here, and this is a 375 coming in, the council standards require that the obvert, or the top, or feet of that pipe, has got to line up. So the drop then is going to be, you know, 450 minus 375.
Standard pipe.
Okay, but most of the standard pipe sizes tend to go up in 75 mil long. Okay, so that drop, the minimum drop is if the pipes are the same, but that's one of the biggest criteria that the council standards have for drainage design, is that obverts, that they line up obvert to obvert. If they are, the other thing is that you never have a smaller pipe leaving than the incoming pipe. Okay, obviously because that chokes the flow. This much water can get into the manhole, and then that much gets out, so it creates a surcharge, and off goes the manhole.
So is that only for different sizes of pipes? If they're the same size, then it can be...
It'll use that.
Okay.
Yeah. There's two things. It'll use the minimum. It'll use the minimum drop up to a point. Later on, there is one difference. The maximum deflection through a pipe for the incoming to outgoing is 90 degrees. There's a calculation based on the council standards for, depending on if it's coming straight through and they're the same, it's going to be 50 mils drop. And the more acute that angle goes, it incrementally goes up until it's, I think it's about 90 mils by the time it gets to 90 degrees. Okay, that's an account, but it's preset in one of your files. So there will be instances, even under a 225 in and a 225 out, that drop will increase, but it's only when it starts to get it, when that bend becomes tight, to allow for the loss through the manhole, the head loss. Make sense? Right, so the last critical bit of information under our defaults here is the pipe size design. Now, for some reason it defaults to pressurised pipe freeboard design. What we are doing is we are designing a part full pipe freeboard design. That will make a massive difference to the size pipe that it gives you if you get that wrong. Okay, so here, we're still under, sorry, just let me get rid of this. We're still under defaults pipes. We're looking at the pipe size design mode. Make sure you change that default of pressurised pipe freeboard design into part full pipe freeboard design. Alright. So what we've done there is we've set the global tab so that we've got the basic models and the type of calculations. I've preset some design criteria under the pipes, pits and catchments. And I'll just run through show you all of those things can then be individually manipulated depending for an individual pipe or an individual pit or an individual catchment under the next 3 tabs. Okay, so it'll take the default first, and then if you set something specific on one of these tabs, we'll overwrite it. So for instance, at the moment under the pipe tab, if I if I changed a value in here, it'll overwrite the defaults for that section of pipe between the upstream manhole and the downstream. If I click on the pit, it's the same thing. It will change the values for that individual manhole.
You don't select flow velocities or anything like that?
You can do. In fact, when it comes to when we create, for it to complete its rational formula here, we will give it a polyline for its for the catchment area. When it comes to wastewater design, it's not the same. You have to work out an individual flow per lot, based on 3 people per house, etc., etc. And then work out how many lots are going into each pipeline, and you have to manually enter in a value for a flow that's going in at that point, whether it's being added to the pipe or the pit. Okay, so that is changing. The latest versions of 12D have got a thing called Tough Flow from Australia, which will calculate or make it more automated, and it also gives you minimum velocities for cleaning and all that kind of stuff, which is council's normally concerned with. But as far as stormwater goes, it's most of the time we just stick to the default. There is one major exception to that. I'm doing a subdivision up at Snells. In fact, that one that we've been working on at the moment, the upstream catchment, which is always the responsibility of a developer, is always is quite often a problem because they've been under-designed either through negligence or because things have just developed beyond what the original design was going to be, and you end up with more stormwater coming downhill than can fit into a pipe. So every now and then we have to allow for it to surcharge through a grill and end up an overland flow, and so I will manually work out how much I want to pull out at different points and redirect into other parts of a reticulation system. And this is the kind of place I can do it. Okay, so when we get into once we start to play around with these things, these are the catchment, pit and pipe tabs are for the specific areas of reticulation. Everything else is a default. Clear as mud? Right. When you get in and start to set this thing up, you start from that right-hand tab and work left. When you start to muck around with the buttons down the bottom, it's the opposite. We start at the left and go right. There is one thing, if every time you hit regrade pipes, set pit details or set catchments, it always prompts you, are you sure? And I find it quite annoying after a while. If you right click on them, it turns that prompt off. Okay, it's only a user preference. So if I turn that back on, if I just start with, so I don't want to leap ahead and confuse it. So if I'm working from left to right, the first thing I need to do is set pit names. I hit set pit names. It's going to use the string name and then a pit number. So my manhole will be manhole 1.1, 1.2, 1.3 up the line. It's a dot because of that string pit separator. I can put pretext or post text that's going to start numbering at 1, etc., etc. Okay, so I'll click run. It either gives you a green, yellow or red highlight. Green, that there's absolutely nothing wrong. Yellow, that there is something happened that's not critical and you just might need to come down to your output window and have a look at the message. It might just be bad pit naming or whatever. It might be something that you can ignore, and if it's red, then it's obviously something you have to go and fix. Back to editor. So the first thing you notice now is that when I click on the pit tab, the pipe ID tells me that I'm now working between 1.6 and 1.5. Okay, I'm going to set pit details. This will make sure that the pit lids, if I've changed any details on them, it'll update the names, whatever I've done. If I've overwritten the Z values, it'll make sure that they go to the whatever I need. But it comes up with this constantly, are you sure? Okay, which drives me nuts. So I just right click on and turn those little functions off. So I set bit details and then I'll click regrade pipes. So if I minimise that now, and again I apologise for this being hard to see at the back, see that the pipes upstream are now aligned perfectly using that minimum drop. Okay, previously some of these the pipe was down lower because of the defaults. It's now come up with a solution that meets all the criteria. Again, starting at 1%. So it's had to drop a couple of these grades down to 1% to comply with the cover. But it's given me a decent first run at what my pipe design's going to be. There's a couple of different criteria as far as design go that I tend to stick to. You've got a couple of responsibilities when you're designing this stuff. You've got to make sure, as I said, that you've got some kind of fat built into it, so that, I mean, we design to an AEP, an annual exceedance probability, but you hear people talk about all the time on the news about the third time this year that we've had a 1 in 50 year storm. It's just a statistical thing. There's nothing stopping us getting bigger and bigger events. In Waitakere, we only designed to a 5-year storm. You know, quite often it goes beyond that. So I like to have a bit of fat up my sleeve rather than designing right to the very line. But you've also got, on the other hand, the bigger the pipe, the more it costs. And you've got, I mean, for me as a developer, my boss is the client, but and so I've got flexibility financially. If you work for a consultancy, every penny is, you know, they got a budget. And any time you spend money you don't have to, it comes off their bottom line, and they get funny about things like that. Okay, so what you need to do is keep the pipe as small as you can without compromising yourself, and also as shallow as you can to keep the cost down. The more that a drain layer has to dig down, the more he has to bench out for safety. Do you understand what I mean by benching out?
Yep.
Okay, so there's a cost involved. The minimum depth, there's cover, you have to have a 1.2 cover over the top of the pipe underneath the road. It's a lot less in private, once it gets into private lots, but you still need some kind of, it's got to be practical. So if you're working at that 1 to 1.2, that's good. When you get beyond 1.8, then you're starting to get into additional cost. Not just cost, but people die in trenches. Okay, they get collapses. We had one of our drain layers went and worked on a job a couple of years ago for 2 weeks in the Waikato, and he was only in a 1.3 metre trench when it collapsed. He just happened to be kneeling over the pipe, so the clay hit him and crushed his chest against the pipe, and he was dead straight away. Other guys have been killed, obviously, in deeper trenches. If the benching hasn't been sufficient, when it comes down, they're just buried instantly. And there's, if the guy's 2 metres down, there's only one way to digging in a hurry, and that's with a digger. And it's, you can imagine there's a few technical problems to. So the whole time it's this balancing act: money over people's safety. Money over making sure that the system's efficient.
If you're designing something that was going to be put in trenchlessly, would there be much difference in how you designed it?
Not really. There's different things you'd have to. You don't have to worry about the same cover problems quite often with trenchless technology. But then the whole thing that's driven you to trenchless technology might be I've got one at the moment where I have to go under some protected trees, so I have to get an arborist will direct how deep I go, so I don't touch root balls. If I need to update a stormwater system now and go under an existing road, they won't let you open trench it without specific permission, and so you then have to comply with the minimum cover under a road. Yes, there's all sorts of that brings in a whole different set of design thoughts and processes. Do you know what he means by trenchless technology? Yeah.
Directional.
Yeah. So which will tend to end up obviously we don't use concrete pipes. Then we'll end up with a PE or something like that. A PE with an NCN 16 rating, so that it's got a certain strength. Yeah. Right. Now we're going for time.
Does 12D have like trenchless pipe calculations, or?
Well, essentially, it's the same calculation. You're still working on its capacity based on on the smoothness of the pipe, the grade of the pipe, and how much water is going to go into it. So how it gets in the ground really doesn't make in the thinking of the design engines. It doesn't really come into it. It does when it comes. I mean, it's more something that you have to be aware of when you think about specifics with the manholes at each end. You might have to make changes to, or the depths or the location of the manholes either side. It's more a process that you as a designer is going to think about rather than what the software needs to think about. Okay. So what we've got here is a basic first run. We haven't run any kind of calculations through it. We haven't given it any kind of flow data. We haven't got any catchments. This is just we've come up with a default solution for that pipe layout based on our preset design criteria. And you can see the kind of things that we can do here so we're still under the pipe tab, and it summarises. We have a pipe 2. If one of these sections went under the road, I could manually go to that and change it to a class 4 pipe. I can start to manipulate things that way. It gives me an upstream and downstream invert, and this is the slightly older version. There's a new one now where you can lock the inverts on this front page under the old one invert design. So if there was a specific reason that I had to leave a pipe invert at a less than the minimum depth, or to avoid a pipe clash, I can manually set it, click on lock downstream invert or upstream, and away I go. I can overwrite any of the defaults here with the grade, alignment mode, cover limits, minimum grades. Okay, all that stuff can be overwritten here under the specific tabs. Right. Excellent. So before next week when we start playing with it, they haven't updated the stormwater license. Unitec doesn't actually pay for the stormwater analysis, but 12D want you to use their software and have an intro into it. So whenever I run a course, I just have to get them to update it. Okay. And without moving on into that, really, that's probably as far as we want to go before next week. That leaves us with 15 minutes. If you do want to have a crack at your assignment, under week 4, there is on Moodle there's an assignment 2 with all the associated files. All the stormwater stuff. I don't know if you've ever used this before, if you've been in an office or work in an office. Under week 5, all those catchment files, drop files, cover files are in there. So feel free to have a crack and have a play with it. But yeah, you can at least move on and get the roads into your assignment. Are there any questions? Honestly, don't look at this and think I didn't take any of that in. All I want to do is run through where things are, and once we start to use it, it will become clear, I promise. Just before you wander off then, is everyone, I emailed everyone a basic rundown of the assignment 1 sheet to your whatever email address was on Moodle. So if I've knocked a couple of marks off or something, I've tried to make a note with some kind of feedback. But honestly, for a first assignment under time pressure, I was pretty impressed with what we got. All right.
You're going to put this on Moodle, this
I have no idea how to put on Moodle.
Can you upload it on YouTube?
Yeah.
How do you do that?
You make it
Can't I just put it on the computer and you just download it off me?
Put it on the shared drive, the student one. Then
Okay.
we all get access.
Do that and email me the file.
I don't think I can because it's pretty big.
Oh yeah.